Welcome to the third day of this bootcamp. And today we'll be using the Mediapipe library. So the Mediapipe library is a library that is used for uh, also computer vision, but more towards detection and detecting faces, hands, and then overall the body. And it was developed by Google. And the advantage of using this library is that it runs only on CPU. And you can run this on almost anything. They have documentation for Android apps. If you're like building an Android app, you can integrate this in Python, on web using JavaScript. You can integrate this library almost everywhere, but today we'll be using Python. And these are the main three projects that we will be doing. So they have face features detection, which just basically detects the facial features. You will just draw vertices around different points of the face. I'll show you later. And there's also hand detection, which is just like this image, draws vertices around the hands, and then we can later get the X and Y position of these vertices. And then finally, we have the whole body detection, just like this image, which is called pose detection. Okay. So let's jump right in. So this is the folder that I sent you 30 minutes ago. And we'll just create a new file. Let's call this Mediapipe hands.py. Be careful not to name the file just Mediapipe because that's the name of the library. And then Python will think that you're trying to import this file instead of the library. So yeah, just be careful not to name it just mediapipe.py. Okay, nice. So the first thing that we will do is import Mediapipe itself. Import Mediapipe. That's the very first thing to do. And the second thing we need to do is import CV2 because we'll also be using OpenCV to get the images or get the video frames and then do the detection. Okay. Then there's one more import that we have to do for Mediapipe, which is import mediapipe.tasks.python, and then let's change this to from. So from this, import vision. Okay. From this directory, import the vision file. So these are the imports that we will use. And then let's define some variables. First thing we need to define is the model path. So this is using models, which they've put inside these task files. So there's this task file, these two, this one. So now we're trying to detect the hands. So we will use the hand land marker. So we'll just pass hand marker task. Okay. This is the model path. And also let's define the OpenCV capture, which is cv2.video capture. We'll be applying this to a video. And then for this one, let's choose hands first. Hands.mp4. Just the video. Okay. Next, we will have to define something called options. So these are the options that we'll pass to the detector. And we need to define them in using the class that Mediapipe library uses. So we'll do vision, which is the import that we did just now. And then we'll select the hand landmarker options, which is what we want to define. Okay. And this takes two arguments or maybe more. The first one is called base options. Okay. These are like the model path. It's the same for every type of detection that we will do later. We'll have to pass the base options, and these are just the path to the model, which is the model path that we just now defined. So we'll have to say Mediapipe dot tasks and then dot base options. And then we'll pass the model asset path. Path is equal to our model path. Okay. So this is the first option that we need to pass to the hand landmarker detector thing. Okay. The second thing that we need to pass is the mode that we want, whether it's an image or a video or like a live stream. Okay. So we define this by assigning the running mode variable. And then this has in Vision something called running mode dot video, because we want to run this as a video. Okay. These are all the options that we need to define for the hand landmarker and the others also. There are more options, but these are like how many hands that you want to detect and so on. So we can add this. I want to show you where you can see these options. So if you go to the Mediapipe Solutions website, which is this one, and then you can have all the solutions here. We're using the hand landmark detection. Okay. So if you go here, you can see these are the options. Running mode, which is what we now declared as video. And then there's also a number of hands. So let's set these to 2, for example. And then there's also the minimum for the detection confidence, for the presence confidence, and so on. But for now, let's just set the number of hands to be 2. Okay. So all we have to do is at the end here, add number of hands and equal to 2. Okay. Nice. The next thing that we can do is say using this or with the vision dot. This time we'll not use the options, the actual self. And then you'll say create from options. Okay. This function takes the options that we just defined and then initializes the detection. Okay. And then we have to say as something. So let's say as a landmark, for example. Okay. So inside this with statement, we can start to receive the frames from the video, just like we did yesterday. So we'll check if it's open while the cap is opened. Opened. We'll read the cap. Cap.read. Okay. Before I continue, are there any questions so far? Oh, okay. I can give you some time to write after me. I'll wait for like 2 minutes if someone wants to write. Try to fit this all, close this. Not sure if you can see everything, but let me know if you want to scroll. Okay. Are there any questions about this part? We're just setting the options. We still haven't done any detection or display. Then- Okay, done. Nice. So after we read the frame, the next step you want to do is to convert this frame into a Mediapipe image. Okay, so there is a function for this. Let's define a variable, call it as MP image, which is short for Mediapipe. And then let's say this is a Mediapipe image. Okay, and then let's pass the format that we want. So there is an image format argument, image format, and then they have a type for this, which is Mediapipe dot image format, and then dot sRGB. Okay. Then the second argument that we have to pass is the data itself, which is the frame. So these are the requirements to turn this into a Mediapipe image. Okay. Then after we've got our Mediapipe image, we can get the results from the detection directly. Say face landmarks, for example, is equal to the landmarker that we defined, and then detect for video. Okay. And then we have to pass two things. The first thing is the image that we just got. And then the second thing is a timestamp, supposedly. So the way we define this timestamp is just, let's say, timestamp equals 0 here. And then every frame, we're gonna increase this timestamp plus equal 1. Okay. So now this should detect the face landmarks and return them inside this list. What we can do then is say for face in face landmarks, dot face landmarks for some reason, because this returns a lot of different stuff, not just the landmarks. And we're only interested in the face landmarks, just happens to be the same name. And then we'll loop also through the landmarks in this face. So for landmark in face, we're using hand, sorry, not face, hand, and 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 hand. Okay. For every landmark in this hand, we want to draw maybe a circle around this so we can visualize the vertices. Okay. So we'll use the same CV2 circle method that we used yesterday. And we'll apply these changes to the original frame. Okay. Now the center point is going to be landmark X and landmark Y. But the thing is, these landmarks are not in pixels. Instead, they are normalized for the entire image. So they return something like 0.5, which is 0.5 multiply the width of the image if it's the x value, and multiply the height of the image if it's the y value. So we need to multiply this by the dimensions of the image. So let's get the dimensions. Equals frame to shape. And then we will multiply the x value with the width, which is the second value, not the first. And we'll do the same for the y. But that's not all. The pixel is supposed to be an integer. And now if you multiply like 0.5 something something, multiply 1080, for example, the result will be a float, not an integer. So we need to cast this to an integer. Okay. And then the radius, let's make it something small, like 3, for example. And let's make the color red, for example. The thickness, we can just say -1, which fills the circle inside. So it's not the thickness of the border anymore. It just fills the entire circle, becomes a solid circle. Okay. Yeah. And then finally, we will show this image. So same as yesterday, cv2 dot im show, image show. Let's say hand, and then we'll pass the frame. Same logic also for checking whether to exit or not. If wait key, say 1 is equal to the letter Q, then we will break. Okay. Any questions so far? Kind of overwhelmed. Okay. I can re-explain everything from the start. Okay, let's go through the entire code one more time. The first thing we do is import Mediapipe and import CV2. Okay. We will use CV2 to like get the video and get the frames of the video so we can run the detection on each frame. And then we also import the vision module inside the Mediapipe library. So there's like this Mediapipe library, and then there's a sub module called tasks. And then there's also a sub module inside tasks called Python. And then inside that, there's another sub module called vision for some reason. And then you have to define the model path. And we selected this model. It's not like I didn't create this model. It's on their website. If you go to their website and you scroll down, this is the model that I sent you guys. You just click on latest and then it downloads. Okay. We're using this hands video. So we open a video capture, same as yesterday. And then the way this library works is you define the options first of the detection, which is like, where's the model that we just defined? And then are we detecting a video or an image or a live stream and so on? And then there are extra parameters like how many hands you want to detect, what is the minimum confidence, and so on. Okay. There's this thing called timestamp, and This is just to let the detector know like which frame in the video we are in. So yeah, it's not really important. We just define as 0 at the beginning and then we just keep adding +1 +1. And then using this vision detector that we define the options for here. So it's like create from options, the options that we've defined. And this is the hand detector model. Vision dot hand landmark. Then we loop through the results of this detection. So the results will be like the number of hands, like there are 3 hands, for example. So we say for each hand of these hands. And then we say for each landmark is like the vertices in the hand. So for each one of these inside the hand, we'll draw, well, one circle. Okay. Then we're gonna just show the frame. If someone presses Q, then exit, and so on. Okay, let's run this. See. So these are that it's trying to detect, but you can see that the it's not exactly matching the position. The landmarks are not exactly matching the position. Okay. And this is because we need to cast, okay, this one landmark dimension 0. Okay, this is 0 instead of 1. Okay, my bad. Okay, now it's in the correct position. So you can see it's detecting the fingers and the palm, some of the parts of the palm. And for this hand, for some reason, doesn't detect, maybe because it's not visible. It's not clear enough. But we can change this by, oh yeah, sure, I can send the code now. Can change this by editing the options. So let me just change the options first and then I'll send it. So the option that we want to change is the confidence, the minimum hand detection confidence. So if you lower this to something, the default value is 0.5, which is 50%. If you're 50% sure that this is a hand, then display this. But let's say we decrease this to 0.2, for example. This way, when we run, even if it's not 100% sure that this is a hand, then it will also display. So yeah, we get both hands. Okay. Let me send you guys the code. Okay. Send you the code. Any questions regarding this? Regarding this piece of code? Anything that's not clear? Anything that you want to ask about why we're using this, why something is here? if there are no questions, the next thing we want to do is use this to do something. So now we have this detection of the vertices of the hands. What are the applications that we can do using this detection? So one application that I can think of is counting the fingers. So you can count the fingers when they change, because now we have the X and Y position of each vertex of the hand. So let's say when I want this vertex to be greater than in the Y position than this vertex, so this finger is counted, and so on. You can use this for many applications. You can use this maybe for volume control. You can like get the distance between two vertices, and the more you increase, the more you do something on your PC, or increase the volume and so on. But for today, we'll just be using this to count the fingers on a hand. So let me show you the video first, counted MB4. So this is the video, and we want to say like this is 1. And then when it changes, it's like, oh, this is 2, and so on. We'll display the count here. With this, we have to refer to their model and the position of the vertices. So these are the vertices that we can now see. And the ones that we're interested in are maybe 8 and 6, 12 and 10, 16 and 14, 20 and 18, like 4 and 2, for counting at least. Okay? So what we have to do now is get the X and Y position of, let's say, 8, and then compare it with the X and Y position of 6. And if the Y of 8 is more than 6, we'll count this thing. Okay? So let's go back to our code, and we won't be using this anymore. We don't need to draw all the landmarks. Okay. So our logic will be like hand, and then we'll pass the index that we just saw. So we said like 8 and 6. If hand 8 dot y is less than hand 6 dot y, then we'll increase the count. Let's reset the count at every frame. So let's say count is here, it's equal to 0. And then if this is true, count is plus equal 1. So the reason we're saying less than is because of the OpenCV, the coordinate system. So we said that the more you go down, the more y increases. So if the position is higher than another position, so it's less in the y coordinate. Okay. And then let's add one more if condition with the rest of the fingers. We said like 12, I believe, 12 and 10. Okay. If increases by 4, so there should be 16 and 14. No, not this one. Do the same, increase the count. Oops. And then this one should be 20 and 18. Okay, so these are for these 4 fingers. And then we want for the thumb. The thumb is a little bit different because when you like open your thumb, it goes in the X direction, not in the Y direction. So we want to check the X direction for the thumb, not the Y. So let's check back the index for the thumb. It's 4 and 2. These are the indices. We'll copy this. And let's say if force X this time is greater than 2x. and then we'll increase the count. Finally, we want to put this count, we want to display this count inside this for loop. So cv dot put text, and we'll put this on the frame, and then the text will be like count, and then plus we'll cast the count that we just got into a string. This is a string, str. We just cast it to a string. And then we want the origin point. Let's say 40 and 40 would be fine. The font face is cv2.font complex. Font scale is 1. Let's make this black. And the thickness, let's say 2. That should be enough, right? So what happens is, at every frame, the count is initially 0. And then it checks the position of the hand vertices. For each finger, if the last knuckle is higher than the second knuckle, then it counts, it increases the count, and so on and so on. Okay? Unless, except for the thumb, it detects the X, I guess. Chooses depending on the X. So let's run this and see if we can get the correct count. Okay, so syntax error, I think, because this is inside Python still. So, okay. So count is 1 now, and which is correct. It increases to 5 for a moment, and then now it's 2, which is correct. So it seems that it is working perfectly. 5, 3, and so on. So we've essentially made a program that counts the number of fingers for some reason. Okay? Any question about this? Okay, the link to the Mediapipe website. Let me send. It depends. It matters for the left and right because it will change whether this is greater than or less than. And you could implement something to check if this is a right hand or a left hand, and then based on this, see the thumb. But for the rest, should be the same. Doesn't matter left or right. Just the thumb that, like, if it's the right one, then it will be less than, not greater than, and so on. Okay. Any other question? If no questions, then we will move on to the second type of detection, which is the pose detection. Okay. Will it work for more than, yeah, it does work than one hand. We've set this to number of hands equals 2. So it detects 2 hands. And we're saying that for each hand, so it will run this code, it will run this logic for each hand. The only thing that might not work is this thumb part. For this, you need to like detect first if this is a right hand or a left hand by maybe checking if this vertex is on the right or this vertex is on the right, so on. And then once you do this, then you can set the condition for this. But for now, this is just basic. Okay. Any more questions regarding this? Can work for even more. If you set this to more, you will detect more hands. Okay. Let's move on to the pose detection. So the pose detection is very similar to the hand detection. So I'm just going to copy this file and paste it same, like duplicate, then change the name. And we'll name this pose. Okay. And there is very little that we need to change in order to make this work. We'll just need to change this to pose light, which is the name of the model right here. For the video, let's use jump. And then all we have to do is change these to pose instead of hand. Pose. Okay. There is this. It doesn't matter, but just for our reference. Pose, pose. Then this is pose landmarks. We don't need this logic for the pose. We just want to display, oops, the landmarks. Okay. So for landmark in pose, landmark of X, this is the same. Let's change this to pose instead. I don't think there is anything left with hand, I guess. Oh, I guess number hands here. Okay. This one and this one, not needed for this one. Yeah, then that should be all. They're all like very similar in terms of the code. So if you just change everything from hand to pose, then it should directly work. So if I just run this, it will give you the pose. So this is what we get for the pose. You can see like a vertex at the knee, at like each major part of the body. Okay. And one thing to consider with the Mediapipe library is it's not that accurate, especially when stuff are fast moving. Like if we tried this video instead, you'll see that it's totally not able to keep up with the movements this guy is doing. It's kind of keeping up, I guess. Okay. I mean, we can make the video slower to like notice more the difference. It's still like not that accurate. You can see the points jumping around. Okay. So let's go back to the jump. Let's put this back to 1. Any question regarding this? We didn't change much. And for your information about the vertices location, you can go to this pose landmark detection and then can find, yeah, these are the positions and the numbers of the index of each one. You can see like the definition of each one here also. Okay. Okay. If no questions, Then the next thing that we can do is apply this, and let's say we want to count how many jumping jacks this guy is doing. So every jumping jack will like increase the count. So for this, we'll need to like see every time like the hand index goes over the shoulder index, then this counts as a jumping jack. Okay. So we just need to find the index. Okay, don't need to display them anymore. And then for each pose, we'll check if, let's go back to the indices, check if 15 is more than 11, for example. We only need one hand since he's moving both hands, but we can say like if both at the same time are above and so on. So if pose 15 dot y is less than pose 11 dot y, so his hand went up, we can increase the count. This time we don't want the count to reset every time, so we'll put it outside the while loop. This is the count, increase the count. If we just do this, it will just keep increasing like very fast. Once he raises his hand, once it passes the shoulder, it will just 299, which is not what we want. So we need to add a flag. We need to add something to say, wait until he, not really wait, but just when he lowers his hand again and then goes up for one more jumping jack, then only do you increase the count. So let's say there's a flag and the default is false. And we'll check here if this flag is still false. You can see that this is not really counting. Maybe you got the vertices wrong. Okay, we got 15 and it should be okay. Should be okay. If the pause for 15, let me check. Okay, let's just do this. Not flag, firm, flag equals true, false, count is here, is equal 1. Okay, this should work. Count, put on the frame. Let's try this again. The jumps are not increasing. Maybe there is a problem. I didn't notice something, maybe. Let's add the other condition as well. Let's say the other hand, also, if it's also above his head. So I believe it's 16 and 12. Let's check. Yep, it is 16 and 12. Okay, let's go back. So if his right hand or left hand, I guess for this left hand, if his hand is more than the shoulder and his hand on the right side is also more than his shoulder, if flag is false or if not flag, the count increases by 1. Let's equal 1. The flag is set to true. It should be less than because the coordinate system for the OpenCV is facing down. So the more you go down in an image, the more it something means that the y value is less than uh, the other one's y value. Okay, nice. Anything else that echoes? Okay. This was fucking up the code. Okay. Okay. The count was always 0. It should be only this reset outside. This way it continues counting the jumping and so on. Okay. Let's change the text to something that we can actually see. It's better. So this is how you might apply something like this. Like this is why this is useful. This library is useful because you get the x and y coordinates of like every part of the body. You can use it to like recognize different gestures. I've seen people do like reps, counting the reps with this. Uh, uh, it can be used for a lot of different stuff. Yeah, sure, I can send this code. So yeah. Before we move on, the next topic is the facial features detection, which is also going to be almost the same code. Let me show you. So let's copy this, paste, and rename this faces. Bye. Okay. So now we do the same thing that we did just now, change everything to face. So this instead of pose is going to be face now. And then this one is also face. Visual purposes. But this one is not. This one is required. We don't need this logic. We don't need this too for now. And let's bring back this. Okay. Okay. In face. Let's change the video to bomb. The MP4. So that's it. That's all we need to change in order to use the face detection instead of the pose or hand detection. Okay. So you can see that the face detection gives a lot more vertices, like everything. Can use this in detail. Let's decrease the thickness a bit so you can see better. Let's make it 2. Yeah, this bit more visible. Okay. And the vertices for this is kind of hard to see, not gonna lie. Because the image they have is not high enough resolution. I cannot see the numbers from here, even if I like try to zoom in. It's not visible at all. But I found another picture I have used, which is this picture. for some reason. But the numbers are much more visible here. Okay, so I'll send you also this picture later. But I'm not sure why they chose to have like red text on faces, which and the text is very, very small. But okay. So let's say for this, for the facial detection, we want to count this time the number of blinks that someone does. So we'll detect when like his eyelid approaches the vertex at the bottom of the eyelid. And then if it does, then increase the blink count. Okay. So again, we won't be using this. And now we want to check if face, let's see which vertex that is using this picture. Let's see. For this eye, it's like 159 and 145, I assume. So if face is 159 minus face 145. Or actually, let's make it the other way around because this is greater than this because it's like down or down. If this is less than something, and remember these are still like relative to the width and the height of the image. So if we minus them, like you need to check for a very, very small value from like 1 being like 100% of the image of the width of the image of the or the height of the image. So y it's 159. Okay. So now we're checking just one eye. If one eye blinks, then let's increase the count. That's not what I want to do. Okay. We still have the count outside. Let's keep it outside. We still have our flag. So let's do the same. If not flag, then count increases, flag equals true, and then else here, this flag is equal to false. Okay. So every time the distance between the uh, top eyelid and the bottom eyelid uh, is less than this, we increase the blink count. And let's also show this using the text. Okay, this one is blinks this time. And string count. That should be all. Okay. Then let's try this and see. You can see it increases every time that he blinks, and he blinks a lot. Or keeps blinking every like 0.5 seconds. Okay. That's basically how you use also the face detector. You can do multiple stuff. You can detect if someone is smiling by like seeing if the vertices as at his lips are like higher than another part of his lips and so on. You can do all types of stuff using this. It's very powerful. And this is actually the way that most apps use filters. Like they use this face mesh and then they apply something on this face mesh. So it's really powerful and it only runs on CPU. You can see this is running very fast and it's only on CPU or CPU. So it can run on mobile phones, it can run anything, doesn't need a GPU. So that's impressive. Any question about this? This is like all that is actually useful for Mediapipe. They have other solutions, but I mean other stuff that you can try, but it's not really useful. And the object detection, for example, we will be using YOLO later, the YOLO library. And the way that they're implementing this is honestly annoying. So we'll just implement it in YOLO later this week. And the rest of the stuff is not really uh, useful. The most useful stuff is the hand detection, face detection, and the pose detection that we just did. Okay. So any question in general about Mediapipe? Oh, can I send the, yeah, of course, I'll send this code to faces. Oops. Oh. Uh, Implementing this shouldn't be hard because they have examples too. If you go to their overview, there's like a guide, a code example. I did not follow this guide directly. I followed some of the stuff because for some parts it uses like a lot of code for nothing, but it should be the same. Like I'm just using the their guide to build this code. So this is what you usually want to do when you like see a library. Just go to their documentation. They probably have some examples, and if you have any questions, they probably have the answers inside their documentation. But I see a lot of people, it is like they get stuck in either watching a lot of YouTube videos or random websites, but they don't check the actual documentation for the library they're using. And there's like some stuff uh, you can find except in the documentation. So yeah, you can see this is the data that it outputs. This is the face landmarks that we'll use. And then there's also like face blend shapes and then so on, facial transformation metrics and so on. But it's not really useful. Yeah, the same for the rest. Yeah. If Nice. If no one has any question, I think we can finish early today, much earlier than 2 hours. It's just that there's not much to do for this library, but it's very powerful. And you can do like a lot of projects, a lot of impressive projects using this library. So yeah, if anyone has any question, they can ask. If not, then we can end the session. I notice this library uses sRGB. Is there any way to use that for CVT2, or is CVT2 only using HSV? You can use this. You can convert CV2 image into RGB. It's just we only convert to HSV when we want to detect the color. Otherwise, the normal image formatting is BGR, no RGB. It's the same, but just the order is different. But you can convert an image. Let me show you. It actually looks weird. Let's comment all this. Let's say we want to do frame RGB is equal to CV2 dot color, and then frame and CV2 dot color BGR to RGB. So they have also RGB, but just because they're using BGR, so it won't display like the normal way. If I run this now, it's just gonna look weird. But it's still okay, but some colors might be inverted. Oh, I'm running the other one. Okay, now it'll look weird. Sure. Yep. Now this guy is an alien. This is just because it's using BGR instead of RGB. So if you convert the image to RGB, then it displays wrongly. Okay, still looks funny. Okay. Any other question? Okay, the attendance will be sent in this chat box. So don't leave yet until you fill the attendance. Okay. Later, I might send some projects that you can try if you want using the Mediapipe library so that you can practice and like understand more. Yep. Okay, the form has been sent, so fill up the form.